So in our previous video, we have discussed about the electric potential and potential difference. Now I am going to teach you about the electric potential energy and to find the electric potential energy at a point due to the system of 2-point charges. That is, if we take the two charges Q1 and Q2, then these are separated by some small distance. We already take it as a 2a in case of the dipoles, but now in electric potential we take some distance, that is r. If r is the distance that separates the two charges, but here we have taken the 2 points. If we take here the 2 points, one of them is at infinity, and you have studied about the electric potential, that it is the total work done in bringing or in moving a charge from the infinity to a particular point. Then we can say that it is the electric potential. And what was the potential difference? It is the limit actually, because in between the 2 points we bring a charge from one point to another point, and the work done, that is the work that is done during that process, that is to bring one charge from one point to another point. This work done is called the potential difference. This is actually the potential difference. It is the difference of the potential. And also we have studied about the equipotential surfaces, that a surface at every point of which the electric potential is same. So now what is the electric potential energy? It is something related to energy now, because it's not the electric potential. Electric potential is another thing, that it is the work done in bringing or in moving a charge from infinity to that point, but it is electric potential energy. This particular energy is what? This energy is the energy, the total amount of energy which is required or which is needed to move a charge, but against the electric field. You know what's the electric field? Electric field is the space around the electric charge or any charge body up to which the force of attraction or repulsion can be felt by the presence of any other charge. That is the electric field. So against the electric field, if we move a charge, and of course there will be the energy needed to move that particular charge, that particular charge will be moved due to the energy, that is required energy, and that particular required amount of the energy is called as electric potential energy. Why electric? Electric is something related to charge, so we are moving the charge. Energy, I have already told you, it is the total amount of energy which is required to move the charge at a particular point from, but it is in the electric field, but against the electric field. Okay, it is the electric potential energy. I have written here. Now there are 2 points to keep in your mind, that if we want to move the charge further, we have moved the charge, and the energy required for moving that charge was the electric potential energy. Now if we want to move the charge further, then more amount of the energy is required. If we want to move the charge further in the same direction against the electric field, then more energy will be used. So we can say that extra electric potential energy will be used if we want to move the charge from the point where we have kept that. Whenever I was saying that it is the total amount of energy which is required to move the charge, so from that particular point, if we move the charge, if we want to move the charge further in the same direction against the electric field, then more amount of the electric potential energy will be used. Okay. Now another point is that more energy is required to move the charge in the strong. If the electric field is very strong field, if the electric field is strong anywhere, then it will be definitely very difficult to move that particular charge, because we have to do the work against the electric field and we have to move the charge. So more amount of the energy will be used now, because more will be the energy, more the stronger field can be passed. Okay, we can move the particular charge from the electric field, same given electric field, but against it. So if we are doing something against to another thing, then more amount of energy will be used. So it was all about the electric potential energy. Simply you can say that it is the amount of energy which is used or which is required or which is needed to move a charge from one point to another, again, but against the electric field. That is the electric potential energy. Okay. Now we are going to discuss about a topic which is in your syllabus: electric potential energy at a point due to the system of 2 points. If we have the 2-point charges, okay, and we have to find the electric potential energy, that means definitely we have to bring the charge from the infinity to a particular point. We have to bring the charge from infinity to a particular point. We have taken the 2 points. One of them is O. I have taken charge Q1 at O and charge Q2 at infinity. We have actually, what is our work? What we have to do? We have to bring that particular charge from infinity to a point where we know the value of the electric field in the electric field, and against it we have to bring that charge Q2, but from infinity. We can say that the distance of this Q2 from Q1 is infinity, and we have to bring this at point P. But where is P? P is at the distance of R from Q1. Q1 is located at O, but it is at rest. Okay, so whenever we want to bring this particular Q2 charge at here at point P, so we have to do some work, and that work is stored in the form of energy. Of course, that energy, because we are moving the charge from infinity to a particular point, so this energy, the electric potential energy. So electric potential energy is needed, and we have to find that. We also know that what is the electric potential at a point due to us charge, a single charge. It is the 1 upon 4 pi epsilon naught. It is the 1 upon 4 pi epsilon naught Q upon R. We know this thing only. Okay, but now what is this? This is the electric potential into charge. What is this actually? We know that what is potential? Electric potential is the total amount of work done in bringing a charge, W upon Q. So if we cross multiply it, we get W upon the W is equal to V into Q. V into Q. What is this W? This work is stored in the form of energy. That is, we can say that is electric potential energy. U. What is V? V is the electric potential. And what is Q? Q is the charge. I have written here. What is that charge? We have to bring that. We have to bring that. What is that charge? That charge is Q2. So we can say that it is Q2 instead of this Q. Q2. V into Q2. But we also know the value of V. What is the value of V? Value of V is this 1 upon 4 epsilon Q1 upon R. Why? Because charge was Q1, for which we have to find the electric potential at point P. Okay. Now, after that, what will we get if we put the value of second equation in first equation? We will get, definitely, U will be equal to V, and value of V is 1 upon 4 pi epsilon Q1 upon R. I have written here. So after that, we have Q2, and I have written here Q2. What will it become? It becomes 1 upon 4 pi epsilon Q1 Q2 upon R. I have written here. That was the U. That is, U means electric potential energy, and we have to find that. Now in our today's lecture, we have discussed. We have discussed that what is the electric potential energy, and I have told you, I have made you understand that what is the electric potential energy at a point due to the system of 2-point charges.